Okay, so this is my synthetic data creator. In this case, it's the realistic rendering scene. And there's a camera here that is the user's perspective. I do have Magic Leap Mesh, but I disabled it temporarily because it wasn't really necessary to have it there for the sake of getting this data. um, anyway, every frame, the camera looks at whatever point on the spline, which is, in this case, it'll basically be a 3D scan path. The camera looks at whatever the appropriate part of the spline is at that point. So, this white line is basically I mean, it is a spline, but it's meant to represent the scan path. And to generate the synthetic data, I'm doing it in reverse. So normally you're trying to find the scan path, but in this case, I'm generating the data from it. So it moves like this, and they look at the paintings, and then they look at the lights, then they look down and at these different objects on the table, and it just keeps wrapping around like this. And Unreal Spline library is really good, so this is pretty simple. Like if you hold Control, or sorry, if you hold Alt and drag, you can create another point, which you can then move somewhere else. And that yellow line is a tangent, which normally I don't need to mess with because the auto-generated one's pretty good. I believe you can split it at certain points. Like I believe if you click this one over here and then do duplicate, it will create a point between these, but those that's been unnecessary. The code itself is mostly pretty simple, so well, let me show you the results of when it's actually playing and how the data is getting generated. So if I play this, it is doing this. Right now it's because I have a very high amount of randomness applied to the head rotation at each frame. If I were to remove that randomness, then the camera would just look at the spline path regularly. So it would just look like that. And let's see, what else can I show you before I explain the code? You can also visualize what they're looking at, so, or the ray that's being traced towards the object from the camera. So here it's showing you that red box is what is being hit. And the reason I need to randomize head rotation is because if I didn't, then that red box would just always be in the center of the camera frame. Alright, I'll quickly explain the code then. So there's some code in the spline itself that I'll look at first. And this code is pretty simple. I have some function called push goal. And what this does is it moves the current position on the spline that the user should be looking at along the spline itself. So I had this little well, this red line represents the spline, but I also had this little blue ball, I think, or green ball, that represents where the user is looking at right now. So if I don't visualize those boxes, but I visualize this, you can see the ball moving along the spline. The spline itself is so thin that I don't think the spline mesh is being generated correctly. Or no, I didn't actually, because I can't, it doesn't make sense to show the spline during runtime, so I just disabled it. Anyway, you can see the green ball following the spline, and so this code is doing that. This code is saying, okay, so Unreal computes the length of the spline when you're creating it, and you can get that at any point with getSpline_length. And I also have this value called getCurrentPosition, which is just how long, where that ball is along the spline. If you were to imagine the spline being simplified down to like a one-dimensional line, if the current position is still less than or equal to the spline length, then I'll keep going. Otherwise, that means that it's at the end of the spline, and then I'll just quit the game so that it doesn't render any more images. If otherwise, what it does is it moves the little green ball forward a little bit. There's this function that Unreal has that lets you get well, it tells you the 3D location of that point on the spline. And so I'm using that to set where the green ball should be. And then I'm incrementing this current position by whatever I decide the increment to be. I believe right now it's 1 centimeter. Yeah, because it's a really long spline. If I use the default value of 0.1, it would take forever to render all these images. So that's the scan path itself. I'm not using this timeline anymore. Inside the camera rendering code, it keeps track of each frame. Then event tick is called every frame, so it's keeping track of which frame we're on. It's moving the goal on the spline. Then it's rotating the camera around its pivot. And this code's a little bit messy, but the basic idea of what it's doing is Unreal has this, Unity and Unreal both have this function called find look at rotation, which tells you which rotation, pitch, yaw, roll you need to look at a target point from a start position. So in this case, my start position is the center. Let me move these. So it's a little bit more clear, hopefully. The start position is the center of the screen, which is the screen size divided by 2. That'll be right in the middle of the user's viewport. There's this function that Unreal has called dproject screen to world, which gives you the 3D position of that screen position. And I'm using that as a start position, and the target position is just wherever that ball is on the spline. Then I'm doing the raycast itself. The raycast is shooting again from the middle of the camera to. It's shooting in the direction of that position on the spline, but at a very high distance. So it's shooting at like 1,000 meters. There. Okay, I'm removing the first frame because the first frame is actually not looking the right way. Because initially the camera, I just positioned it arbitrarily. And then it's doing some casting just to make sure that what we're hitting is actually a mesh. Although in this case it pretty much always will be, but there can be things that you hit that are not meshes, like colliders. Then I have this pairing of meshes to labels. So I'm trying to generate the simplified label for any of these meshes. So book LP just becomes book, and mug was already fine, and that's fine, but other things like the bowl, I don't think by any definition this is a bowl, so I renamed it to plate. And for the couch, I just called them both couches and things like that. So that's what this dictionary is doing. Then this whole part is just it's just creating the name of the file. So the file is which frame we're on, underscore, and then the label in parentheses, then the x coordinate, and then the y coordinate of where it is on the screen itself, not in 3D. And then finally I'm just a texture render target in Unreal it's just a texture that saves whatever the camera is seeing at the time. And there is this function that lets you export it as a PNG. The formatting, you need to be careful about the camera's render target format so that it exports correctly and is openable. Like I used this one. You can also do cool things like there are options inside of the camera to store depth inside of alpha. So it's pretty useful if you want a depth map. But right now I'm exporting final color in this format. Final color is the color that it's the color after all of the pre-processing. So if you go to unlit mode, this is basically like, I mean, this is sort of, well, no, it doesn't become unlit when you're doing final color. Final color, I think, is mostly affected by lighting. So if you export it as scene color, what it will do is export the colors as if there is no light at all. I don't remember if there is a visualizer for having no lights. Scene color? Oh yeah, there we go. Okay, so this is what it would look like if you exported it without final color. There would just not be much effective lighting. Oh god. Yeah, that's pretty much it, I guess. It's not a very long script. It's just doing a lot of things at once, because that's what Blueprint tends to do. That's why it's color-coded. Anyway, bye.